Hi, my name is Kaylee Burt, and this is my lab for magnetic field of a bar magnet. The purpose of this lab was to demonstrate the magnetic field of a bar magnet and understand the concepts of true versus magnetic north, and then create a computational model of the experiment and compare the predicted and observed calculations. A preview of my result is the distance dependence N I got was negative 1.41, and then the magnetic dipole moment mu shown here. Fixed principles for this lab, we plotted the log of the magnetic field versus the log of r to find the slope n, which I mentioned earlier, and the intercept b, and then I used the intercept b to calculate the magnetic dipole moment mu, and then the Burt-Savart law to calculate the magnetic field of the dipole bar magnet. The equation I used is shown here. And then the experiment procedure, the system was the bar magnet, the surroundings was everything else, or Earth magnetic field and everything else. And then the initial conditions, the smartphone was aligned to minimize the influence of the Earth's magnetic field along the x-axis. And then we identified the location of the magnetic sensor and set up the bar magnet going east to west. And then we measured the magnetic field on axis using the exponent of the app and calculating the magnetic field at various distances. And then recorded and input that data into a spreadsheet where we got averages. And then we also calculated the off-axis magnetic field by finding dperp and adjusting the magnetic field by accounting for the magnetic field of Earth, and then compared these lab results with the computational model. And then here's just some of the data I mentioned, the observed data. So when we were doing the experiment, the on-axis data is what we got from moving the magnet further and closer on the x-axis to the magnetometer. And then the spreadsheet calculated the averages for us, which are the numbers see here. And then the off-axis field, we calculated the dperp, and the field by the Earth we already knew, and then we put in those values, and the spreadsheet calculated the value D for us and the value of the net magnetic field B net. And then here's just the graph of the log BX versus log R that I talked about and the number that I got for N. And then here's some calculations just to put them all in one place. The N value, like I said, they calculated, and then solving for mu, and this is kind of the formula and the thought process I used to solve for mu. And then the average distance D, which I mentioned, was calculated by the spreadsheet, and so was the average B net. The assumptions for computational model, the model may differ from experimental values due to interference from other lab equipment, electronics nearby, and then improper alignment of the magnetometer bar magnet, also human error. Here's some of my closed script code. I went through and edited the lines that we were told to edit. Here's my mu that I put in there, and then I created a function for magnetic field, and then edited the lines for the axes and the perpendicular observation locations. And then I created 2 arrows to represent the magnetic field on axis, and then 4 arrows to represent the perpendicular magnetic field. And then here's the perpendicular to the right, and then the on-axis or to the left. And then I edited the line to the D that I calculated. I edited the dperp line to match that. And then I just filled out the rest of this code. And then here are the results, the measured results, the results that I got from the experiment. I got that B net is 6.1 times 10 to the -5 Tesla, and then the computational model, this is the value that I got. As you can see, they're a little bit different. We'll talk about why later. And then this is kind of what my code looks like when you run it, and then here are all the values. And potential source of error, like I said, the values were kind of different, so we didn't have an isolated experiment, and nearby electrical equipment could have contributed to error. We could have used a more accurate magnetometer, and then accidentally bumping the smartphone, failing to line up the smartphone went north before starting, and then we also could have run more trials to gain more accurate results. And then the observed versus computational, we calculated a lot more values for the observed model and averaged them, which we didn't do for the computational. And then the observed average distance D is similar to the computed average distance D, so those were similar values from both models. And then differences, the computational model is more accurate as all the possible sources we talked about don't apply. And then, like I said, the measured and computed B nets are a little bit different. What if you hadn't oriented your experiment to compensate for magnetic north and had just laid out your meter stick at some angle with respect to Earth's magnetic field? The measured magnetic field would have been a combination of the bar's magnetic field and a non-negligible component of the Earth's magnetic field. This would have made it difficult to isolate the contribution of the bar magnet alone, and then the presence of the Earth's field could have caused greater variations in the measured value, making it harder to obtain consistent data. If you were to stick 2 identical magnets together, how would you expect the measurements to differ? I would expect the measurements of the B field to be stronger as there's a stronger magnetic force acting on the observation location. However, the directions of the field created by the bar magnet would stay the same. Thank you.